One of the most important concepts you need to understand to apply the Arduino in your own projects is circuitry. Circuitry is an aspect of hardware. In this section, we will discuss the basics you need in order to build your own simple circuits. Here are some of the main concepts we'll be covering: Ohm's law, breadboarding, and types of circuits, parallel versus series. Arduino projects need electricity to run. Electricity works using closed circuits. There are three things which are important in order to have a closed electric circuit: voltage, current, and resistance. Voltage is the potential energy available to the circuit. In smaller circuits that do not require higher amounts of voltage, the voltage is usually supplied by a battery, or the Arduino's built-in voltage supply. All voltage supplies have two ends. One end has high voltage, shown by the positive sign on your battery, and the other end is at the lower voltage and is also called ground, shown by the minus sign on your battery. The current is the actual energy that flows through the circuit. Resistance is a factor which regulates the current. The relationship between the voltage, current, and resistance is expressed through Ohm's law. We will not go into much detail, but it is important to understand that different aspects of the circuit influence each other. Now that you have an idea of how circuits work, let's jump in. The breadboard is a prototyping tool you can use with the Arduino. It is not necessary, but using it allows you to keep your circuit more organized and easy to understand, especially when lots of wires are involved. The breadboard contains metal strips that connect certain areas of the breadboard. As you can see on the multimeter, these are the connected bus strips. By connecting different areas of the board, the current is now going over both of these strips. There are two main circuits used to build things: series and parallel. In a series circuit, there's only one path for the current to follow. This means that if any components, say a light bulb, break or are removed, the circuit will no longer work. In a parallel circuit, there are multiple paths for the current to follow. Components connected in parallel each receive their own current. If one of the light bulbs in a parallel circuit burns out, the rest will continue to function because they are each receiving their own current. You'll notice that in both circuits, resistance is provided. This regulates the current and in turn prevents overheating of the circuit, which would damage the components. In this case, the bulb would break. Now, let's build both types of circuits so you can understand them in a more practical way. Follow along with your breadboard and pause the video anytime if you need to. So, first, we'll set up a series circuit. Let's first open an example in Arduino. Open the Arduino platform. Before opening a program, let's check that our equipment is in sync with the Arduino. First, go to Tools, and then Board. Make sure that your board type is selected. Next, go to Tools again, but this time check the port. If you are unable to determine which port to choose, disconnect your USB from the computer and see which port disappears. Now go to File, Examples, Basics, and then select Blink. Unplug your USB cable and copy the following layout on your board. We unplug the board while building to avoid blowing the circuit. Know that for LEDs, what end you put where matters. The longer side should go to the positive end, and the shorter side to the negative end, or the circuit will not work. When these positions are switched, you may end up blowing your LED. So if you're doing it the right way and it still doesn't work, try using a new LED, as yours might be broken. When you have your board set up, plug in your USB and upload your program to the board. Try pressing down on both buttons and you should hopefully see your LED light up. It only lights when both buttons are pressed because this is a series circuit. Unless both buttons are turned on, the circuit is not completed. Now let's build a parallel circuit. Unplug and adjust your board so it matches mine. When you're ready, plug in your board and upload the program again. Try playing with the buttons and you will see that the LED doesn't care. Push either one of the buttons or both together and the LED will still light up. That's because in a parallel circuit, the current has multiple paths to flow through. Here are the two circuits in tandem. So, to recap, in this chapter you have learned the three main components of a circuit: voltage, current, resistance, and how they work together in the circuit. what a breadboard is and how to connect different areas of the board to create a circuit using the breadboard, and the difference between series and parallel, the two main types of circuits.